Hello Algebra 1 students, welcome to your video on relations and functions. Lots of vocabulary in this video, so I'm not going to waste any time. I'm going to get started right away. We're going to be working on words like relation, function, domain, range, zeros, and intercepts. So lots and lots of new concepts here. Let's get moving. A relation is a set of ordered pairs. A set of ordered pairs that may or may not have a relationship. So a relation is just any old set of ordered pairs that you see that you're given. Okay, the domain is the set of all the x values. That's the input. It's the independent variable. And you can remember that it's the independent variable because when you learned this stuff in previous years, you had a function rule or an equation and you changed the x, which says independent variable to me because if you think about science, that's your manipulated variable. Then you have your range, that's your output, that's your dependent variable. Again, going back to our example up here at the top, once you plugged in your x value, your y value was your output. It's what came out. It's what depended on what happened with the x variable, the x value. A function is a relation where each input has exactly one output. So in other words, x values cannot, values with an S, cannot repeat. X values cannot repeat. Okay? For a relation, you have to be able to display it. And so you might have a list of ordered pairs as your display for a relation. So say you have the ordered pairs -1, 3, 0, 0, 1, -1, 2, 0, and finally 3, 3. That would be an example of a relation. It's just a set of ordered pairs that's given to you. You can also display that as a table. In a table, you would have the x's and the y's. You'd list the x's down, -1, 0, 1, 2, 3, and then the corresponding y values next to them. 3, 0, -1, 0, and 3. So that would be your table. A mapping is a very specific method of displaying a relation. I'm going to move it over here. You start off with two ovals. You put your x values in numerical order in your left-hand oval. You put your y values, again, in numerical order in your right-hand oval. So -1, 0, and 3. And then you draw arrows between the x's and the y's that go together. -1 goes to 3. 0 goes to 0. 1 goes to -1, 2 goes to 0, and 3 goes to 3. And that's a mapping. A mapping actually is a very good way to tell whether or not you've got a function going on right here. Okay, something we will address probably in class rather than in this video. A graph, well, we have our graph. It's over on the right there. Okay, so our graph, which is literally just points on a graph. You know how to do that. And then later, get to this part later, we will be able to take that information and write an equation in function notation for a relation. Well, specifically for a function. So let's talk a little bit more about functions. How can you tell whether or not you have a function? Well, if it's a relation, you get a set of ordered pairs. That set of ordered pairs might be discrete, so it might just be points on a graph, like that, or it might be something more continuous, like these three different displays you have here. If you just have points on a graph, you can examine just your domain. Or if you have a list of ordered pairs, you can just look at your domain. If you have repeated x values, it is not a function. But if you don't, if you have a graph, you have a visual you can use. And in that visual, you can take what you have, the information you have, and you can figure out, no, I didn't want it to be that color though, hold on. I want it to be this color. There we go. Oh, that's not what I wanted either, hold on. What I wanted was to have a line where I can use for the vertical line test here. There we go. So there's my line for my vertical line test. So here's the deal. If you think about what's on this line right here, every x value is the same for all the points on that line. That means that if our function, if our relation here, if this line, if I take this vertical line and I go to pass it through the relation and it touches it more than once, that means there are 2 points that have the same x value and it's not a function. So I know it's hard to wrap your brain around this, but you'll get there, I promise. So again, if I take my vertical line and I sweep it across the relation and it touches it 2 times, then it can't be a function at all. It's just a relation, it's not a function. Is that the case with this one? No. So a linear relation is immediately a function. This line is a function, as long as it's not a vertical line. How about this one over here? Well, let me write that in. Hold on, let me write that in. Yes, that's a function. How about this one over here? Well, if I take this and sweep it across, all of these points. At all of these stages, it's touching 2 points. We'll stop right there. Definitely not a function, because there are 2 points that have the same x with different y's. In this case, to be specific, I could actually graph those 2 points. Let me move this over here so it's out of the way real quick. Like this one and this one. Definitely not a function because of those. What about this one, this curved one over here? Nope, doesn't ever touch more than 1 point. So that one is, again, yes, that one is a function. All right, so we have the vertical line test. We can examine the domain. There is a third way to test whether or not we have a function, and that's to use a mapping. We're going to do that in class. So you can also use a mapping, and we're going to do that one in class. So make a mark in your notebook and make sure that we do get to go over that in class. Types of functions, we're going to deal with 2 specifically and in detail later on in the year with the second one, but we're going to deal with linear functions. That's one whose graph is a non-vertical line. So any diagonal or horizontal line, no vertical lines, because then it immediately fails the vertical line test. A vertical line cannot pass the vertical line test because every point on it has the same x value. A quadratic function is one, I did not mean to write on it. A quadratic function is one whose graph is a parabola, and you just saw that on the previous slide. You may not recognize that word yet, but you did see it. Here's another example, or here's the same example again. Let me shrink it down smaller. That is a parabola. It's not parabola, it's not Ebola, it's not a disease, it's a parabola. So please make sure you accent the correct syllable, parabola. And that's called a quadratic function. You can remember that by writing the word quadratic with a parabola. And we're going to talk more about those in the third marking period, quadratic functions. Now, we need to be able to find domain and range from a graph. And this is all about saying what the x values are and are not for a particular function. So in my first function, okay, well, relation in this case, because one of these is not a function. You probably already recognize which one, because I'm using the same examples again. But in this first one, we have to determine what the domain and the range are. So when you identify the domain and the range, what you're going to do for something like this, because the domain here is a low of a -2 for x and a high of a +2 for x, you're going to display that with an inequality. X is between 2 and -2. So x is anything from -2 up to 2, including -2 and 2. That's the or equal to's. What about the range? Well, the lowest value for the range here is -1. This time I'm going to make it less than or equal to y for the range, and then less than or equal to, and the high value is a 2. So the domain is from -2 to 2, and the range is from -1 to 2. Inclusive. Inclusive meaning it includes these points on the ends, because you got these filled in circles. The next one is a little easier to find the domain and the range. You're actually just going to list it in curly braces, because we can just find them. It's a discrete relation. The domain is -1, 0, 1, 2, and 3. -1, 0, 1, 2, and 3. Oh, that's a comma. Sorry. All right, and the range, again, discrete. -1, 0, and 3. And we don't list those numbers twice. We list them in numerical order. And yes, those details are important. It's something you'll have to replicate. So sometimes you'll have an inequality like this, where it's between 2 numbers. Sometimes you'll have just a list in curly braces in numerical order with no duplicates. And sometimes you have something a little different. Now let's look at this one. The domain for this one Well, this parabola keeps going to the right, keeps going to the left. We get to assume that it keeps on going forever to the right and forever to the left. That means that there isn't going to be any point where it turns around, and that means the domain is all real numbers. Just like when you solve an equation and it comes out to be an identity, the domain is all real numbers here. Because any x can be found on that curve if you go out far enough to the right or far enough to the left. But the range has a minimum. The range has a lowest value. So that one is going to be an inequality with y. Y is greater than or equal to -2. Because the lowest point we can have is -2, but it's anything above that. Okay, let's come look at this line over here. So for this one, domain and range. Again, I want to think about, can it keep going forever to the right and forever to the left? Yes, it can. The domain is all the real numbers. What about the range? Will it keep going forever up and forever down? It sure will. So the range is all real numbers. And that will happen now and again. In fact, any linear function is going to have that domain and that range. This next one has limitations, so we're going to have one that looks more like the first one we did with the red segment, this green circle. The domain, the smallest number in the domain is -3, the highest is 2. So from -3 up to 2. And then the range is the lowest, again, -3, and the highest, 2. So from -3 up to including 2. So that's probably the most difficult concept or the most difficult task you're going to have from this video is finding that domain and range, but we'll practice it in class. Okay, zeros and intercepts. The x-intercept of a function is the point where the graph of the function crosses the x-axis. Intercept sounds a lot like intersect. Intercept and intersect. So we are talking about where this line crosses or intersects with, gosh, I had trouble spelling today. We're talking about where this line intersects with the x-axis, and the same thing for the y-intercept. That's where it crosses the y-axis. Now, x-intercepts have another name. They're also called zeros. So the x value of a function is a zero of the function if the y value of the function at that point is 0. So where y equals 0, the x values there are called zeros. Where y equals zeros, those x values are called zeros. Kind of hard to do by definition, so let's just look at some examples and finish this video up. And the zeros in each case. Now on the first one, you can't tell me exactly what that 0 is. You'd say, oh, it's -1.5. Well, we don't know that. We don't know how specific we can be here. But we can say that this function has a 0 between -1 and -2. And another one between +1 and +2. Okay, how about the next one? So on this line, where's the 0? Where again, we're talking about where the x value has a value, but the y is equal to 0. Those are zeros. So in this one, this has a 0 where x equals -1. That's a 0. And this last one, we should also be able to see, has 2 zeros, -1 and 3. We'll see more about quadratic equations much later. We're going to be going into lines in more detail pretty soon. Hope this wasn't too much information in one video for you. Try to go back. Try to make sure you know all that vocab. See you guys in class.